Hello everyone. In the last video, we wrote two functions for the first time. We wrote a function called f and a function called checkIfEven. In this video, we're going to return to our GPA computation fun.cpp file and rewrite that entire solution to apply top-down design and functional decomposition in order to define functions to solve all of our sub-problems in our GPA computation fun file. Before we do, I just want to recap just to review some of the terminology and see how programs are executed that have functions in them. I think it will greatly help if we do this with a problem we've already solved before we head over and solve some new problems. So let's recap. Program execution always starts with the main function. Always, always. So let's take a look at the main function. This whole thing is the definition for main. This first line here is specifically called the function header. The function header consists of the return type. So here, main's return type is an integer, which makes sense because we're returning an integer value 0. Then we have the name of our function, which is called main. We don't get to choose the name of this function, but we do get to pick the name of our other functions, like checkIfEven. We made that name up. Then we have our open paren, close paren, and inside of the parens is our parameter list. If there are any inputs to this function, we would have to specify variables, one for each input, in order to store those incoming values. Then we have curly brace, and everything in between the curly braces is the body of the main function. The body of our function executes from top to bottom. So we have a call here to checkIfEven. A call causes a function to be executed. If there are no calls to a function, that function never executes. Even though there's a definition for checkIfEven, there has to be a call to checkIfEven in order for the body of this function to execute. So we encounter a call to checkIfEven, which means that our flow of execution now pauses in main and shifts to the function checkIfEven. We have an argument of 3 that is being passed in as an input to our function. So 3 is copied into num. So I'm going to draw a variable to represent num. Num now stores 3. We enter the body of checkIfEven, and we have another variable called isEven that's declared, and it's initialized to false. So I'll put 0 in here to represent false. Then we come down to our next line of code. If num mod 2 equals 0, then we'll set isEven to true. In this case, num is 3. So this evaluates to false. We don't set isEven to true, and we return isEven. So isEven now takes the place, figuratively, of this function call and is printed out as part of our cout statement here. When this function finishes executing, all of the variables that are declared inside of this function, checkIfEven, are deallocated, which means they can't be used anymore. These functions are called these variables are called local variables because they are local to this function only. So these are now gone. They could not be used in main because main can't see them. They're only visible within checkIfEven. We'll have a whole video dedicated to the scope of a variable or the scope of an identifier. but we're not quite there yet. But this is just kind of a prequel or a little overview of what's to come. But very important concept to know, scope. All right, so this line of code is finished executing, so now we move on to the next line of code. We call check if even again, this time passing in 10, which is copied into num. Then we execute check if even again from top of the body to bottom of the body. So we have a variable called is even, which is allocated again, initialized to false. We test, is num mod 2 equal to 0? Is 10 mod 2 equal to 0? It is. So we enter the body of this if statement and set is even to true. So I'm going to overwrite my 0 and put a 1 in here. And then we return is even. So the 1 is returned and is printed out when main resumes. This function exits, main resumes, and check if even return 1, 1 is printed out. Then we return 0, and that exits our program. There is no more code to execute. And those went out of scope when we exited this function. All right, now let's code up a lot of examples. Go ahead and open up GPA computation fun.cpp. All right, let's first define a function for getting the grade point for a course. That way we can reuse it here, here, and here. This function is going to return a grade point, which is of type double. Right now, our prompts are specific for the course, computer science, math, and karate. We'll come back and change that so that it is specific, but for now, we're just going to use really general prompts. So let's cut this code, paste it, and take out the computer science part. We're just going to prompt for any old course. But like I said, we'll come back and change that. We need to declare a variable called GP in order to store the grade point that the user enters. Instead of using GP1, let's just use GP because it's general, because this function is going to be called for multiple courses. It doesn't matter the number of the course. This is a general get grade point function. And then we've got to return that GP. So now we have a definition for get grade point. Remember, this code won't execute here until we call get grade point. So let's call get grade point. It doesn't accept any arguments, so we don't put any in here. It does return a value, so we'll want to store that value in a variable. Since this function call is for the first course, we'll store that return value in a variable called GP1. Now let's replace our other get grade point code to make use of our reusable function get grade point. Awesome. We can see our main function is getting a little bit shorter and a little bit cleaner. Let's run our code and make sure everything is working so far with our new get grade point function. Note that our prompt for getting the grade point doesn't say something specific about computer science, math, or karate anymore. It just says grade point for your course, grade point for your course, grade point for your course. That's because each one of these prompts is coming from our get grade point function, and it's general and doesn't have anything specific for what course we're prompting for. Let's go ahead and change that now. We can pass an input into get grade point that specifies the label we should insert here for the name of our course. So we'll need a string parameter in order to do this. Let's call it course name. We'll use course name in the middle of our cout statement so we can get that nice customized prompt that has a label for the name of the course we're prompting for. That means that when we call get grade point now, we have to specify a string as an argument. In fact, if we don't, we'll get a compiler error. Here's what the error says. Line 17, that's right here. Error, too few arguments to function double get grade point. And here you can see it expects a string, but there isn't a string. So the compiler can be helpful to help you figure out if you have any problems. Always read the first compiler error first. So our first prompt should say computer science, our second prompt should say math, and our third prompt should say karate. Now let's see if we can get our customized get grade point prompts back. And we do. Please enter the grade point for your computer science course. Please enter the grade point for your math course. Please enter the grade point for your karate course. Cool. So I have a task for you. Go ahead and define and call the get number credits function. You can use the get grade point function to serve as your model. Voila, we have two functions, get grade point and get number of credits, which we can use over and over and over again anytime we need a grade point and number of credits for a course. This is pretty cool. Now, we're not quite done. We could define a function to compute the weighted credit hours earned. We could define a function to compute the total number of credits earned. We could define a function to compute the average of the grade points, and we could define a function to display the results to the user. Now you might be thinking that seems kind of like overkill because we won't be calling those functions multiple times in this program like we did with get grade point and get number of credits. And you would be right, we aren't going to call them multiple times in this program, but it still makes our code more readable, reusable, extensible, and maintainable if we write functions for every single one of our tasks. That way our code reads really clearly. Main becomes a sequence of function calls where every function is well named such that we know exactly what the code does. For example, this expression here is kind of complicated and it's maybe not really clear what this code's supposed to be doing. We have a nice comment here, but if we assign weighted credits, the return value from a function call called compute weighted credits, then our code gets shorter in main and it gets more readable. We could also then be able to test our compute weighted credits function on its own and make sure that it's correct. And then we could reuse it in this program and other programs, feeling pretty confident that it's correct. So if you head over to the notes for today, here are the additional functions to go ahead and write code for. I'll turn you loose with this task. I think you're up for the challenge. Go ahead and write these 4 remaining functions. And if you get stuck with something, try and debug it or just tune back into the video because I'm going to go ahead and code these up now. One thing I want to note before we move on, when you call a function, you do not specify the data type of the variable of your argument. So for example, the first argument to my call to compute weighted credits is GP1. So I'm passing in the variable name GP1. I'm not also putting the double data type in front of it because we're not declaring a variable here. We're using a variable. We put the data type on the parameter here because we are declaring a variable. It happens to be that I named GP1 the same in main and as a parameter in compute weighted credits. Those do not need to be the same name. Those are 2 completely different variables. So it's up to you as a programmer if you keep them the same name or not, but do know they are completely separate variables. Changing GP1 in this function, for example, does not change GP1 in this function. They are completely separate. The only way to communicate a value back from a function that we've learned so far is via the return statement. After you write a single function and call it, that's a good point in time to save, compile, and test. I would not ever recommend moving on to write another function before you fully tested the one you just finished. Looks good. Moving on to the next one. In this one, I'm going to purposely use a different variable name than numCredits1. Just so you can see that these do not have to be the same name. All right, now I need to call this function. I'm done writing a function and calling it. Now's a good time to save, compile, and test, and make sure that I didn't introduce any errors. Looks good. Moving on to our second to last function, compute GPA. I'm going to be a lazy programmer here, and I'm not even going to declare a variable to store the GPA. I'm just going to compute it and return it in the same statement. Since this is a double and this is an integer, this will be floating point division, which is what I want. I want a fractional part on the GPA. So far, so good. We're at the home stretch. We've got one left. I like writing designated functions for displaying results for several reasons. One, it gives a lot of practice, specifically with using the void return type, because typically your display functions don't compute anything, so they don't return a value. They only display a value. I also like to write functions for display results because it keeps our program very, very modular, such that we don't have this cout statement in the middle of main that looks kind of like a debugging statement. Instead, this is going to be a call to a function, and the function is not there for debugging. It's part of the core modular design of our program. By the time we get done with this function, main, it's going to be all function calls, and there won't be any cout statements, which will make it really short and really clean. Since our display GPA function doesn't return any values, the return type is void, which means nothing is returned. All right, write a function, call it, save, compile, and test. And it all looks good. So here's that implementation also in the notes, recalling one function is one task, one algorithm, and writing all of these functions so that our main is really just a beautiful sequence of function calls really achieves that rule of thumb or exemplifies that rule of thumb. All right, Take a break, you deserve it. You have learned a lot in the last couple videos about functions. We're going to move on in the next video to some new topics related to functions, specifically how they execute and why we use them. Stay tuned.